small town. Okay, anyway, let's do geo. We are on the top of page 15. So we got a lot to get through. We got to get through this. We got to get through a trig packet. And we got a review game to do. So stuff. So this is, oh, you need a geo packet. Anybody else need a geo packet? Here you go, my dear. No problem. All right, so what did I say? Top of page 16? The fans are blowing my stuff all over. No, top of page 15, 1-5. Top of page 15, 1-5. Okay. So SAT number 3, we have a hexagon problem. Okay. So the regular hexagon shown to the right is divided into 6 congruent equilateral triangles. I will argue that every single hexagon you come across can and should be divided into 6 congruent equilateral triangles. What is the measure in degrees of one of the interior angles of the hexagon? Okay, so this right here, interior angles, that's the key part of this problem. Everybody thinks an interior angle is one of these guys. It is not. That is a central angle. It's not an interior angle. Okay. An interior angle is a fancy word for a corner. That's all it is. So an interior angle of the hexagon would be like this down here. It's the corner of the hexagon. Okay. Now, what do we know about these triangles? They're equilateral, which means every single angle in these triangles is equal to what? What are the corners, what are the angles in an equilateral triangle equal to? Equilateral. What does that mean? They're all equal. And if they're all equal and there's 180 degrees in a triangle, how much is each angle worth? 60 degrees. Every single angle in each one of these triangles is worth 60 degrees. So that's 60 degrees, this is 60 degrees, this is 60 degrees, that's 60 degrees, and this is 60 degrees, which makes the corner of that hexagon 60 plus 60, or 120. Okay. So it's 120 degrees. Now there is actually a formula to figure out like what each angle of a hexagon is worth, but meh. Why remember another formula when you can just figure out the triangles? Okay. Today we have a mouse. All right, ACT number 3. In the figure below, square ABCD. I'm so glad they told me this is a square because it sure as heck doesn't look like one. Square ABCD is attached to triangle ADE as shown. If angle EAD is 30 degrees and AE is equal to 4 root 3, then what is the area of the square? Okay, so if we know this is a square, then we know the length and the width are the same, right? So to find the area of a square, it's just like finding the area of a rectangle. It's just length times width, but we know they're going to be the same number. So once I found one, I got the other. So I'm just going to label CD. I'm going to call that the length. And I'm going to call AD the width. You can do that backwards if you want. Doesn't really matter. I need to find one of them. Well, W is on my triangle, and triangles are my friends. So I'm going to try to find W that's hooked up to this triangle right here. And on this triangle, I have a 30, 60, 90 triangle. So that right there is going to be my buddy. So let's go play with that. Okay, so I got a 30, 60, 90 triangle. I'm going to go ahead and draw out my pattern triangle that goes with that. So across from the 30 is my little guy A. My hypotenuse is 2 times the little guy. And that leaves my third side to be the ugly A root 3. Now, match up your sides and find A. So if I match up my sides, okay. If I match up the sides that I was given, right here, if I match those dudes up, then A root 3 has to equal 4 root 3, which means if I just match things up, A has got to be 4, right? Just use a little common sense there, no real math. Okay, A is 4, which makes 2A equal to 8. If I put that back in my picture, W must be 8. So if W is 8, I can find my area. Again, my length and my width are the same. This is a square, supposedly. So this is going to be 8 times 8, which is 64. So my area is 64. questions? Cool. Moving on. All right, next up I believe is circles. Okay. Circle problems. So there's lots of funky equations with circles that y'all learned in school. The good news is, for the most part, you're not going to need to know them. The equation you do need to know that you didn't learn in school is this three-parter right here. Okay, every single piece of this is what we call a part over whole. Okay. So we have the degrees and sectors. So if they give you an angle, that's where it goes. Your angle over 360. And that's equal to the area of the sector. Now, what do we mean by area of sector? Okay, well, let's draw a picture. All right, so we got a spiffy-diffy circle. Kind of looks like an egg. When we talk about a sector, what we're really talking about is some sort of pie wedge. Okay, some sort of pie piece. So this right here would be your sector. Okay? Your degrees in sector would be whatever this angle measures right here. That would be your degrees in sector. Your area of sector is exactly what it sounds like. It's the area of that pie wedge where it's shaded. So area of sector over area of circle. Area of circle is pi r squared. That's equal to your length of arc, so that's your arc length. That's going to be the distance along the outside of the circle. This is arc length. Divided by the whole length around the circle, which is your circumference, 2 pi r. So again, each one is part over whole. Okay? Any questions on this formula? We're going to look at how to use it in a minute. Okay. When you go to use this, you're only going to use 2 of the 3 parts at a time. So depending upon what you're given and what you're looking for, you may only be using the first 2, or the first and the third, or the second and the third. You're always going to throw out one section of this equation. Okay, other important formulas for circles you need to know. Your circumference is 2 pi r. This is on your formula sheet for your SAT. Of course, your ACT, you don't get one, so you need to know that. Your area is pi r squared. Your diameter is 2 times your radius. That is not on any formula sheet, but you do need to know it. And then your basic circle equation. This is for a circle in a plane. X minus h squared plus y minus k squared equals r squared. H and k is your center, r is your radius. Also not on your formula sheet, but you do need to know it. Okay. Any questions on basic circle information? All right, let's do problems. Oh, why for you zoom? You're not supposed to zoom. There we go. That's what you're supposed to do. Technology. You're killing me. Okay. SAT number 15, let's look at this. Points A and B lie on circle O, not shown. So of course, the first thing we're going to do is attempt to draw some sort of thing that looks like a circle. And since it says circle O, that means your center is O. A and B lie on this circle. Okay, great. I'm going to put A up there. I don't really know where to put B yet, so I'm going to hold off on B, but I'll put A up there. AO is 3. Okay, cool. That means the distance from O to A is 3. Got it. Angle AOB is 120. That kind of tells me where to put B. B is going to be somewhere down here. And we're just going to kind of estimate that angle and say, okay, cool, that's 120 degrees. Got it. What is the area of minor sector AOB? Don't get caught up on this word minor. A minor sector just means it's under 180 degrees. A major means it's over. But we don't really care. It doesn't enter into our calculations in any way, shape, or form. Okay, go back to your 3-part equation. Let's look at what we're given and what we're looking for. Well, we're looking for the area of the sector. So we know we're going to need the part of the equation that says area of sector over area of circle because we're looking for the area of the sector. So I know I'm going to need that. So area of sector, we're going to abbreviate. Area of sector over area of circle, which is pi r squared. I'm going to need that part. And then my other options in that equation is either angle over 360 or arc length over 2 pi r. I know nothing about the arc length. It said nothing about arc length at all. So I don't want to use that piece. So I'm going to have to use angle over 360. And they did indeed give me an angle, so I can plug in there. Okay, so let's plug in what we know. Area of sector is what I'm looking for, so that's my x. Pi r squared. Pi, my radius. Well, my radius is right here. It's 3. It's the distance from the center to a point on the circle. So that's my radius. So pi times 3 squared equals my angle, which is 120, divided by 360. And this is a calculator problem, so simply cross multiply and solve for x. Now your answers have pi in them, so don't multiply your pi in, just kind of carry it through. So we get 360x equals a large number, 1080 pi. And then solve for x by dividing both sides by 360. And we should get 3 pi. Again, we just kind of carry that pi through almost like it's a letter. So we get 3 pi. Just see. Questions? That's how we use that three-part equation. That way you don't have to know the arc length formula. You don't have to know the area of sector formula. You can simply just use the three-parter and you're good to go. Okay. Next one is yours to do for practice. Again, you're going to be using that three-part equation. You're just going to be using different parts. And let's look at 22. The circle defined by the equation that has its center point at 4, 4 and includes 0.78 on the circle. This is shown in the figure to the right. What is the area of the circle? All right, well, let's start with what they're asking for. What's the area of the circle? So area of the circle, area formula for a circle is pi r squared. So I need my radius. I can get my radius out of the equation, or I can get my radius off the picture. Let's do it from the picture. The center is at 4, 4. 1, 2, 3, 4. 1, 2, 3, 4. That's right there. And then to get my radius, I'm either going to count straight right, straight left, straight up, or straight down until I hit the edge of the circle. So I'm going to go straight up. 1, 2, 3, 4, 5. Boom. So that's a distance of 5. So my radius is 5. So that's pi times 5 squared, which is 25 pi. And that's my answer. Okay. All right. The next one, SAT number 15. This is a question that only shows up in your, yes ma'am.
What was the point of the equation for that then?
It's another way that you could have gotten your radius.
Okay.
So this equation is x minus h squared, y minus k squared equals r squared. So right here, this is r squared. So you could have picked that up as being r squared. Yeah, so they just gave you two ways to get your answer. All right. This guy, number 15, this is an SAT only question. Does not show up in your ACT at all. And this only shows up like every other SAT, so it's not a real popular question. Thank God. The graph of this lovely thing in the xy plane is a circle. True statement. What is the radius? Well, in order to figure out what the radius is, we need to have this in our standard form. That's a k, which looks like that. Okay. Now, in order to transform it into that form, we have to do a process called completing the square, which I don't expect you to remember how to do. Hopefully the words at least sound familiar. All right, so here's what we're going to do. First thing we're going to do is take any constant, so it's negative 24, and throw him on the right-hand side. He is in our way and does not need to be there. So x squared minus 4x. Give yourself a little bit of room. Plus y squared plus 6y. Again, give yourself a little bit of room, and chuck that 24 to the other side. Okay. When you're setting up for completing the square, the idea is that you're going to wind up factoring these x's into a perfect square and factoring your y's into a perfect square. So that means I'm going to have to actually add a number here and add a number here in order to be able to factor that. I'm going to create two trinomials. But this is an equation. Whatever I do to one side, I have to do to the other. So if I'm adding two numbers here, I need to add those same numbers on the right side. Okay? All right, now to figure out what goes in that blank, you're going to take half of your middle number and then square it. Okay? And we don't care about this sign. Ignore the negative. So half of 4 is 2. 2 squared is 4. So we're going to put a 4. And again, whatever I do to one side, I got to do to the other. So one of my blanks over here needs to be a 4. Same thing with this guy. I'm going to take half of my 6 and square it. So half of 6 is 3. 3 squared is 9. And again, we'll do the right. Now we're going to factor. We're going to factor the x's by themselves and then the y's by themselves. So x's, I need factors of 4 that add to give me negative 4. So that's negative 2 and negative 2. So x minus 2 times x minus 2, or x minus 2 quantity squared. Same thing with the y's. Factors of 9 that add to give you 6. So it's 3 and 3. So y plus 3 and y plus 3. Or y plus 3 quantity squared. And then the right side, we're just going to put this together. So 24 plus 4 plus 9 is 24 plus 13 is 37. Now we're in our right form. X minus h squared, y minus k squared equals r squared. So r squared is 37, which means r is root 37. Just see. Again, shows up like every other test. Not a real popular problem. But because it shows up like every other test, if you saw one of those, you're like, why didn't she teach me this? So now you've seen it. Okay. All right, any questions before I get rid of it? All right, next up is an ACT only problem. So this is an ACT only problem, and it has to do with the standard definition of a circle. So, standard definition of a circle actually goes exactly how this is written. In the standard xy coordinate plane, the circle centered at 1, 3 that passes through 4, 7 is the set of all points that are something. So again, let's draw a picture of what's going on. We have a circle. Well, we have an egg, but it's supposed to be a circle. It's centered at 1, 3. We know it's passing through 4, 7, so that's somewhere over here. Okay. Now, so it's the set of all points that centered at 1, 3 that passes through 4, 7 is the set of all points that are 5 coordinate units from 1, 3. Okay, so in other words, do all points that lie on this circle, are they exactly 5 coordinate units away from the center? Well, I don't know. How would we figure that out? How would we figure out if the distance from here to here is 5? What would we use? Sir?
Find the radius.
Right, how would I do it? Okay, fair enough.
No, that's what you're supposed to do.
Yeah, you are. You got 2 points. How do you find the distance between 2 points? Kind of. What do you mean by subtract? I can't subtract them directly because they're not exactly on top of each other or directly next to each other. These are at an angle. How do you find the distance between 2 points? Don't we have a formula for that? Something maybe called the distance formula? Yeah. Okay. So distance between 2 points, we want to use the distance formula. That long thing with the square root. x2 minus x1 squared plus y2 minus y1 squared. Okay, does that kind of come to mind? So let's see if the distance between those 2 points is 5. If it is, then our answer is probably A, B, or C. Okay? If it's not, then we can rule A, B, and C out. This is the ACT. They're not going to screw with your brain. They're not going to put a number in there and then not have it be the answer. Okay, so square root x2 minus x1. So I'm going to call this x1, y1, and x2, y2. So x2 minus x1 is going to be 4 minus 1 squared, and then we got 7 minus 3 squared. So that's the square root of, let's see, 4 minus 1 is 3. 3 squared is 9. 7 minus 3 is 4. 4 squared is 16. 9 plus 16 is 25. Square root of 25 is indeed 5. Okay, so the distance from here to here is indeed 5, which means your radius is 5. Which means my answer is probably going to have the number 5 in it. The radius is a pretty important part of the circle. And again, this is the ACT. They're not going to screw with your brain. Put the number 5 on there and then not have it be the answer. The SAT would probably do that to you, but the ACT won't. So, A, B, and C. Is the circle the set of all points that are 5 coordinate units, 1 radius away from your center? So in other words, if I go 5 units in any direction from my center, so 5 that way, 5 this way, 5 that way, will I still be on my circle? Well, yeah, that's kind of what a circle is, right? If I go a radius in any direction from the center, I should hit the circle. A is looking pretty good. Let's go to B. Is the circle the set of all points that are 5 units, 1 radius, away from both 1, 3, and 4, 7? You're shaking your head, why? Right, what if I went a different direction? What if I went that way, 5 units? Yeah, no, I'm no longer on the circle, so that fails. C is out. C is out for the same reason. They just added the word line segment. God only knows why. So it's got to be A. Okay. All right, that's how we work through that. Any questions before I get rid of it? Yay, nay. Okay, good. All right. So adios to distance formula. Number 30. No, not up there. Down here. Now you don't want to scroll? What happened to you? Did you just die? No, there you go. Okay. Which of the following equations describes a circle with radius 10 that passes through the origin and graphed on the xy plane? Well, let's start with that radius of 10. If the radius is 10, what should the right side of my equations be? Oh, you guys are quiet this morning. If the radius is 10, what should the right side be? Like pulling teeth. Okay, so x minus h squared plus y minus k squared equals r squared, right? Your radius is squared on this side. So if your radius is 10, then your right side should be r squared, which would be 10 squared would be 100. So the right side should be 100. So that's going to rule out A. The other thing we know is that it's going to go through the origin. So your coordinates of your origin are 0, 0. So that means when I plug in 0, 0, my equation should work. So if I plug in 0, 0 to B, you're going to have 0 minus 5, that's 25 when you square it. 0 plus 5, that's 5. 5 squared is 25. So I got 25 plus 25. So 25 plus 25 is not equal to 100. That's equal to 50. Rule out B. C, same idea. Plug in 0, 0. 0 minus 10 is 10. 10 squared is 100. 0 minus 10 is 10. 10 squared is another 100. 100 plus 100 is not equal to 100. Rule out C. Answer's got to be D. And if you plug it into your calculator, it'll work. Yes, ma'am?
Where'd you get the 0, 0 from?
It says it goes through the origin. So if it goes through the origin, your coordinates of the origin are 0, 0. Ma'am?
How come in the formula it's x minus h and y minus k, but in that one there's a plus?
So, in which one is plus? Oh, like right here?
Oh, no,
In D. Oh, okay. So, all it means is if this is plus positive, then that means the coordinates of this center are actually 5 root 2 and negative 5 root 2. Okay? So, if it says in your formula that x minus h times y minus k gives you the center h and k, then when you actually look at an equation they give you, you change the signs on both of these in order to get your coordinates of your center. Okay? Anytime you have a negative in your formula, just switch the signs on these guys to actually get the coordinates of your center.
So it doesn't always have to be negative.
No. No, these negatives just mean switch the sign. That's all that negative really means. You'll find that a lot in math and physics. It just means change the sign. It doesn't really mean negative. Okay. Any other questions on that one? That was a good question. You made my brain work as to how to explain that. So I like that. That keeps me on my toes. All right, ACT 36. These are, again, typically only ACT questions. I don't see these too much on the SAT at all, on these pie charts. So Joe asked 90 students to choose one favorite fruit from 4 options. Joe has begun to represent the results in the circle graph below. Peaches were chosen as the favorite of 15 kids. Apples, bananas, and strawberries were each chosen as favorite among equal number of the remaining kids. What must be the measure of the central angle of the circle graph called bananas? All right. So we're going to have bananas, strawberries, and apples. And they want to know what the central angle is going to be for bananas. So this is another part over whole question. Okay. So first I have to figure out how many kids actually want the bananas. So we're starting out with 90 kids. 15 of them already want peaches. So I can discount those guys. They don't want bananas. So 90 minus 15, that's 75. And then we also know that apples, bananas, and strawberries were each chosen favored by an equal number of the remaining kids. So I got to split that 75 up 3 ways. So 75 divided by 3 gives me 25. So 25 kids wanted bananas. So I got 25 kids wanting bananas. So that's my part. 25 kids wanted bananas out of a whole, which was 90. We started with 90 kids. On the other side of my proportion, I want to know what angle out of the circle, how many degrees out of the circle bananas is going to get. So again, I'm missing that part. What part is bananas going to get out of the whole? How many degrees are in a circle? 360. Anytime you're asked for a central angle in a problem, your right side will always be x out of 360. You're just going to have to figure out what the left looks like. And then cross multiply. So 90x equals a very large number. I think it's 9,000. Because I'm pretty sure you're supposed to come up with 100. Okay. Any questions on the central angle stuff? They do like their central angle problems. All right, next page, number 15, is yours to do for homework. And then we're going to talk about 3D shapes. So 3D shapes, a lot of people kind of freak out about them, but they're actually really straightforward problems, okay? The test makers seem to think that 3D formulas are really difficult, which they're not. So they don't make the problems that hard. Bonus for us. So number 15, a sphere has a volume of 36 pi. What is the surface area of the sphere? You are not expected to know surface area formulas. Hence, they gave it to you in the problem. Surface area of a sphere is given by area equals 4 pi r squared. Okay. The volume of a sphere, that formula is on your formula sheet. Let me move this up a little bit. A little more room to work here, people. There we go. So the volume of a sphere is 4/3 pi r cubed. That's your volume. Okay. They asked me for the surface area. I know I need my radius to get it. The only way I'm going to get my radius is from my volume. So let's fill in what we know. We know the volume is 36 pi. So I have 36 pi equals 4/3 pi r cubed, and I have to solve that for r. So the first thing I'm going to do is get rid of those pi's. I can divide both sides by pi and just cancel it out. So I'm left with 36 equals 4/3 r cubed. Let's get rid of the fraction. So to get rid of the fraction, I'm going to multiply both sides by the reciprocal, which is 3/4. That'll nix my fraction. 36 times 3/4 is 27. So 27 equals r cubed. I don't want r cubed, I want r. So to undo my r cubed, I need to take the cubed root. So the cubed root of both sides. The cubed root of 27. You should have a cubed root button on your calculator. So the cubed root of 27 is 3. Once you have your r, you can find your surface area. So surface area formula is 4 pi r squared. So we have 4 pi times 3 squared. 3 squared is 9. 9 times 4 is 36. So my surface area is also 36 pi. So in this particular case, your volume and your surface area are the same. That will only happen if your radius is 3. If your radius is any other number, that does not happen. Ma'am? For a cube or a box, like a rectangular shape, you would just find the area of each face and then add it up. So those you kind of do manually. There's no real formula for it. Okay. That's that, dude. ACT number 5. We're going to do that one for homework. It's pretty straightforward. When it tells you to use 22/7 as approximation value for pi, you don't have to do that. You can just use the pi button on your calculator. You get the right answer. ACT 43, also try that for homework. Again, pretty straightforward. Let's look at other shapes. So we like working with our basic shapes, our circles, rectangles, squares, and triangles. We prefer to work with those, but there are times when we have to work with other things like trapezoids and parallelograms. So let's take a look at those real quick. SAT number 5. In the figure to the right, BC and AD, is no longer on the screen. BC and AD are parallel. Okay, so BC and AD are parallel. AB and EC are parallel. CE is congruent to CD. The measure of ABC is 115. That's marked. What is the measure of angle BCD? B to C to D. So that's this whole angle up here. That's what we're looking for. Okay. All right. So our goal here is to find that whole angle. Well, I can't get that whole angle off the bat. This is a trapezoid. It's a parallelogram with a triangle. But I don't know for sure that this is an isosceles trapezoid. If it is, then I would know that 115 and this is also 115. I would know that these two angles are equal and these two angles are equal. But it doesn't tell me in the problem it is isosceles, and I can't make that assumption. So I'm going to have to actually go through and figure it out. So I'm going to work with just the parallelogram, ABCE, this guy right here. So in a parallelogram, you know that opposite angles are congruent. So if this is 115, then angle E down here is also 115. And then you know that, hubby must have fixed the AC. You also know that all 4 angles in a parallelogram add up to 360. Okay, all 4 angles in any quadrilateral add up to 360. So you can add the 115s together, subtract it from 360, and then split it in 2 to get your A and your C. And I believe that comes up to be 65. So that's going to be 65, and then this part of the angle up here that's inside your parallelogram, this part is 65. So now we just need the part that's inside the triangle. So let's work our way into that triangle. So let's start down here at the bottom. You've got 115 on the left side of E, and you know that that angle plus the angle on the right has to make 180 because that's a straight line. So that means the angle on the right side of E is going to be 65. Bless you. Now again, let's look closer at this triangle. We know that 2 sides of this triangle is equal according to our problem. If these 2 sides are equal, then that means that these 2 angles are equal. It's an isosceles triangle. So the 2 sides are equal, the 2 angles are equal. So this is 65, and that's 65. Now, in a triangle, there's 180 degrees. So add these up, subtract it from 180, you can get the top. The top is 50. And then you can put those two numbers together to get your whole angle. So 60 and 55, or 65 and 50 is 115. So it does actually wind up being an isosceles trapezoid. You just can't make that assumption based on the information they gave you. Hoy, yes?
So this line is parallel. Aren't the 65s and 115 alternate interior angles?
Yes.
You can just do a main one.
Yep, you can do it that way too to get the 65 and the yep. Absolutely. Okay. All right, on to shaded area problems. Okay, so in rectangle ABCD to the right, over here, E is the midpoint of BC. So E is the midpoint of BC. And then F is the midpoint of AD. AB is 6, AD is 10, which makes this 5 and 5. What is the area of the shaded region? Okay, so these tests love their shaded area problems. The easiest way to figure these out is not to actually usually find the shaded area, it's usually to find everything else. So take your outside shape and subtract off the parts that aren't shaded. You always want to think in terms of your basic shapes, your rectangles, your squares, your triangles, and your circles. So my outside shape is my rectangle. So I want to use that. And always write yourself a quick plan. My shaded area is going to be my outside shape, which is my rectangle. And then I'm going to take off those two triangles that aren't shaded. So minus 2 times my triangles. If you write yourself a quick plan like that, it's going to be much easier in case you get lost in your calculations as you go. Okay? So rectangle, let's start with that. So the area of a rectangle is just length times width. So length is 5 and 5, that's 10. Width is 6, that's going to be 60. Triangle is 1/2 base times height. So we've got our base, that's 5. To get our height, well, just apply a little common sense. If F and E are the midpoints, then you must be splitting this sucker in half. So half of 6 is 3, so this is 3 and this is 3. So my triangles, I'm going to have 1/2, my base is 5, my height is 3. Half of 15 is 7.5. Each triangle has an area of 7.5. Okay. Plug that back into your plan. Your shaded area is your rectangle, which is 60, minus 2 times your triangles. So 60 minus 2 times 7.5. 2 times 7.5 is 15. 60 minus 15 is 45. B. Okay. All right. Next one is yours for homework. And then we'll do the hexagon problem. Thomas is making a sign in the shape of a regular hexagon, God only knows why, with 4-inch sides, which he will cut from a perfectly good rectangular sheet of metal, as shown in the figure below. What is the sum of the areas of the 4 triangles that will be removed from the rectangle? So we want to find the area of these 3 guys, plus the one in the upper right here that I'm not going to shade in because we're going to draw in it. So again, my plan, my shaded area, is 4 times the area of one of my triangles. Okay. Well, I have a hexagon. Hexagons can and should be divided into 6 congruent equilateral triangles. So here we go. There we go. 6 congruent equilateral triangles. What do we know about equilateral triangles? What do we know about their sides? They're all equal. So if their sides are all equal, then this is 4, this is 4, this is 4, and most importantly, that side of my triangle is 4. Okay? What do we know about their angles? They're all equal and they're all 60 degrees. So this is 60 degrees, that's 60 degrees. This is 60 degrees. This is 60 degrees. What does that leave me for that red angle inside the triangle? You've got 60 here, 60 here. It's got to make 180. It's a straight line. So that's got to be 60 as well. Okay? So I've got 60 inside this right triangle. That makes this a 30, 60, 90 triangle. All right, let's pull that triangle out and make it bigger. And we know this side is 4. All right, let's draw our pattern triangle next to it. Across from the 30 is the little guy A. The hypotenuse is 2 times the little guy. That leaves the third side to be the ugly A root 3. Match up your sides and find A. So 4 is equal to 2A, which is going to make A equal to 2 and A root 3 equal to 2 root 3. Okay. Your shaded area is 4 times the area of a triangle. Let's find the area of this triangle. So the area of a triangle is 1/2 base times height. Now if we have a right triangle, it's always the 2 legs that form the right angle. So we're going to use the 2 and the 2 root 3. So 1/2 times 2 times 2 root 3. 1/2 and 2 cancel. So the area of each triangle is 2 root 3. Now put that back in your plan. Your shaded is going to be 4 times 2 root 3. And that's 8 root 3. Which is A. Notice that this is a number 29 on a multiple choice. That means it's pretty far along in the test, so it should be a pretty hard problem. Any questions on that? Okay. Okay, 18 is yours to do for practice. And then the whole next page, 29 to 32, is also yours to do for practice. And that's the end of geometry. Okay, so trig and advanced math, we're going to cover parts of this. We're not going to actually cover the whole thing. Mainly because there aren't that many questions on this on the test. When it comes to trig on your tests, oh, I need to give you guys packets. That would probably be really helpful, right? Whoa. Stuff everywhere. Trig. Yep. No problem. No problem. One for Joe. Oh, you got one. Yeah. There you go. Yep. 2 more. No problem. All right. A little crooked, but that's okay. Okay, when it comes to trig on these tests, on your SAT, you'll see between 4 and 6 trig problems. That's it. All but one of them will be SOHCAHTOA based. When we talk about SOHCAHTOA, what we're talking about is right triangle trig. So sine is opposite over hypotenuse. That's where you get the opposite over hypotenuse. Ka Cosine. Cosine is adjacent over hypotenuse. That's where you get the ca. And then TOA is tangent. Tangent is opposite over adjacent. That's where you get the TOA. Okay? Hopefully most of you guys have seen this and may hopefully remember it. You probably saw it at the end of geometry or the end of algebra 2. And may have seen it again after that. Okay. When you go to set up your right triangles, and always draw a right triangle for these problems, you're going to mark one of your angles. You can mark it with the Greek letter theta. You can mark it with an X. You can mark it with a purple star or blue triangle. I don't care. Just mark it in some way, shape, or form that you know which angle you are dealing with. I usually put a hash through it. Once you know which angle you're dealing with, then label your sides, opposite, adjacent, and hypotenuse. Hypotenuse is the easy one. It's always across from the right angle. So you know there's your hypotenuse. Your opposite and your adjacent will switch depending upon where your angle is. Okay? Your adjacent side is always the one that's closest to your angle. Okay, so it's always touching your angle. And it's not your hypotenuse. So the side that's touching my angle that's not my hypotenuse is the bottom in this case. So that's my adjacent. Which means the side over there that's not touching my angle has to be my opposite. Now if I switched angles on this, so same triangle, but swapped angles. Instead I'm going to work with that angle instead. My hypotenuse stays the same because again it's always across from my right angle. But this time my adjacent, again, is the side touching my angle that's not my hypotenuse. So my adjacent would be over here. And my opposite would be at the bottom. So they will switch if you switch angles. Okay? All right, so that's kind of really important because that's going to be your basic step 1. If you don't get this step right, you're not going to get any of the trig problems right. Okay, so make sure you know how to identify which side is opposite, which side is adjacent. All right. Now let's look at how this shows up on your test. Here we go. SAT number 15 and triangle ABC not shown. So of course we're going to draw it. AC is perpendicular to BC and cosine of angle ABC is 12 over 13. What is the value of tangent of the same angle? So first thing we're going to do is draw a right triangle. It doesn't matter which way you draw that triangle. Just give yourself a right triangle. So there we go. I need to get my letters in the right place. I'm going to use this perpendicular statement right here to do that. Okay, so I look for which letter repeats itself. C is the one repeating itself. That means C is my right angle. So C goes down here in the right corner. A and B don't matter. They can go wherever. So I'm going to put A down here and B up here. I could do that reverse, but that's the way I'm going to do it. It says cosine of angle ABC is 12 over 13. So we're not really used to seeing it as cosine of angle ABC. We're used to seeing cosine and then just a letter. No big deal. Just pick out the middle one. That's the one you want. So really, cosine of B equals 12 over 13. That's the same statement. Cosine. So cosine of B equals 12 over 13. Okay. So cosine, so ka toa, right? So ka toa. Favorite abbreviation ever. We're in cosine land. We're in the middle. Cosine is adjacent over hypotenuse, A and H. So adjacent over hypotenuse. All right, let's label those sides. Across from your right angle is your hypotenuse. Now I'm dealing with B. I'm dealing with this angle. So that makes my adjacent the guy next to it. And my opposite the bottom. So my adjacent is 12. My hypotenuse is 13. Okay, any questions on how I got those numbers? All right. They asked me for tangent. Tangent? Tangent is TOA, opposite over adjacent. Well, that's a problem. I don't know my opposite, but I have two sides of a right triangle. How can I get the third side of any right triangle if I have the other two? Pythagorean theorem, my favorite dead Greek guy. All right. So, opposite squared plus adjacent squared has to give me my hypotenuse squared. And if you work that out, your opposite side is going to be 5. Okay, so opposite over adjacent is going to be 5 over 12. Right there, boom. Okay. All right, next one is yours to do for homework. It's the same thing, only it's an ACT question, so there's fewer words. SAT 35. Let's look at how they can kind of mess with this. In the right triangle below, sine of theta is 2 over 5. So remember, that's the ratio of the sides. That doesn't have to be equal to the sides. That's the ratio of the sides. Lots of other fractions are equal to 2 over 5. If AC is root n, what is the value of n? So let's write down what we know. Again, let's ID our sides real quick. If this is theta, we know this is our hypotenuse. Next to theta is my adjacent. So this has to be my opposite. Okay, now what do we know? We know that sine of theta is opposite over hypotenuse. Okay. And we also know that sine is equal to 2 over 5. They told us that. That's the ratio of my sides. Again, it doesn't have to equal my sides. It's the ratio of my sides. So fill in what you know. You don't know your opposite, but you do know your hypotenuse. Your hypotenuse is 10. So I don't know my opposite, but I do know my hypotenuse. It's 10. And that's supposed to be equal to the ratio of 2 over 5. That will let you find your opposite. So cross multiply and solve. 5x equals 20. X has to be 4. So my opposite side is 4. Now you have 2 of your sides. You can set up your Pythagorean theorem and solve for n. So root n squared plus 4 squared should give you 10 squared. Root n squared is just n. Plus 16 gives you 100. So n is 84. Sir?
If sine is opposite over hypotenuse, how does 2 over 5?
That's why I keep saying it's the ratio of the sides. So it's the ratio of the sides. It doesn't have to equal the sides. That's something that is not emphasized to you guys enough in school. Lots of fractions equal 2 over 5. Okay? 4 over 10 would work. What? Times 3 would be 6 over 15. This is the ratio of the sides. It's not equal to the sides. Okay? I teach a lot of trig kids, and I don't think that that's taught to you guys in school ever. It's the ratio of the sides. It's not equal to the sides. Does that help clear that up?
Yeah.
Okay. Screws you up for this, and it'll screw you up later in calculus. Okay. All right, any other questions on this? Cool. Okay. Next one is yours for practice. It's not really that bad. Let's look at 23. This one really isn't that hard either, but the way it's worded is a little weird. In a right triangle, the tangent of one of the 2 acute angles is root 3 over 3. Okay, so got a right triangle. Again, I just have to pick an angle, and it really doesn't matter which angle I pick. So I'm going to start with this one down here. I'm going to call it theta. So they're telling me that the tangent of one of my angles is root 3 over 3. Again, this is TOA, opposite over adjacent. So if I'm using this angle, this is my hypotenuse, next to it is my adjacent, and this is my opposite. So opposite we're saying is root 3, and adjacent we're saying is 3. Okay. So we're going to use that. Now, they're saying what's the tangent of the other angle? So I'm going to switch angles. So we're going to up here work with this one. We're going to call it x. So they want me to find now tangent of x. So if I switch angles, my opposite and my adjacent are going to flip. So this is now my adjacent side, and this is now my opposite. So, but tangent is still opposite over adjacent. So my opposite is 3, and my adjacent for this angle is root 3. So the tangent of x, the tangent of my other acute angle, is 3 over root 3, which they didn't rationalize for whatever unknown reason, so that's D. Okay. Questions? Yes?
If you rationalize that, wouldn't it be square root of 3 over 3?
It would be, if you rationalize this, you'd have root 3. You'd have 3 root 3 over 3. So you'd wind up with root 3. Any other questions? Okay. Whoop. There we go. Similar triangles we can skip over. It's not going to happen. I don't think I've seen a similar triangle problem on the test in the last 2 years for trig. ACT number 44, this will happen to you if you take the ACT. So your ACT likes to really kind of screw with your brain when it comes to trig, only when it comes to trig. Otherwise, they're straightforward. They like to take, okay, so SOHCAHTOA, sine, cosine, tangent, this should be done on right triangles. They like to do right triangle trig on things that aren't triangles. It's like, that shouldn't happen. So they're going to give you some kind of quadrilateral and say, hey, find the tangent of this angle. And you're like, wait a minute, that's not a triangle. So you're going to have to make some triangles. So quadrilateral ABCD is shown in the figure to the right with the lengths of the 4 sides given in meters, not that we care about the units. The measure of angle C is 90. What is the tangent of A? So we're looking for the tangent of A. But again, I can only do right triangle trig, sine, cosine, and tangent, on things that are triangles. This is not a triangle. So I just need to make some triangles. So I have to decide where to put a line in order to make 2 triangles. Okay. And I kind of have 2 choices. I could go from C to A, or I can go from B to D. Well, here's a right angle right here. I want to take advantage of that. So I don't really want to split them up. So I'm going to go from B to D. Okay. So I want to find the length from B to D. Well, I can do that. I'm going to cover this side up. I can do that using this triangle on the left. I have legs of 3 and 4, and my hypotenuse is from B to D. I know B to D is my hypotenuse because it's across from my right angle. So use your Pythagorean theorem and get your length from B to D. So 4 squared plus 3 squared equals your hypotenuse squared, and that should come out to be 5. Okay, for those of you that know your Pythagorean triples, it's 3, 4, 5 triangle. Now I'm going to ignore the triangle on the left and just work with the triangle on the right. Okay. So if I just look at the triangle on the right, I have to decide where my right angle is. Well, it's easy enough. Look for your biggest side. Your biggest side is 13. So that has to be your hypotenuse, which means your right angle is directly across. So boom, boom. So we have a 5, 12, 13 triangle. Okay. All right, once we know that, we just need the tangent. So tangent of A is opposite over adjacent. So adjacent, hypotenuse, opposite. Opposite over adjacent is 5 over 12. B. Okay. Again, ACT only problem. Okay. The last 2 trig problems are non-SOHCAHTOA trig problems. Now they're ACT problems, but these could show up on either test. Okay, so the graph of this lovely trig function is shown in the standard xy coordinate plane below. What is the range of y? So they just asked you for the range. This has nothing to do with trig, okay? They just want the range. They want low and high. That's all they want. So if I look at my low, well, my low here is about -2, give or take. So if I look at my answer choices, I want -2. So it's got to be either B or C. My high is somewhere above 6. Well, the only one that has a high above 6 is C, so my answer's got to be C. Again, I didn't have to know anything about trig to solve that problem. But because it's a non-SOHCAHTOA trig question, actually it's a high difficulty rating. Okay. All right, one more. Now we're done with trig. For all x such that 0 is less than x, which is less than 90, which of the following expressions is not equal to sine of x? If you know trig IDs, you can solve this using trig IDs. Most people don't remember those. No big deal. These have letters in your answers. What do we do with letters in our answers? Yeah, plug in a number. And it tells you right here what kind of number you need to pick, something between 0 and 90. So pick a number between 0 and 90. How about 10? 10's between 0 and 90. So if x is 10, and we're in degrees, we want to know which one is not equal to sine of 10. So let's find sine of 10. What's sine of 10 degrees? Somebody run that through a calculator. What gross and disgusting decimal do you get? Okay, so that's what we're trying not to hit, because remember, we want the one that's not equal to it. Okay, so if you plug in 10 into each one of your answers, the only one that should not give you this answer is B. It should give you negative of that answer. It should give you negative 0.1736. Da, 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 da. So again, don't have to know anything about trig to do this. Just do our usual strategy, plug this stuff in. Okay. All right. Next up are log problems. Okay, guys, log problems are all about how you put it in the calculator. That's all it is. Log problems are ACT only problems. These are actually really straightforward. So you have the paper in front of you. There we go. Okay, so you should be able to see you can see my calculator on the screen. So your first problem is log base something. Log base 2 of 8. Okay, so to do log base 2 of 8, if you have a TI graphing calculator, all you have to do is go into your math menu. So your math menu, your math button is right underneath your green alpha button. Okay, so underneath your green alpha button, you hit the math button. It'll bring up this menu. You're going to arrow down until you see log base. It'll look like that. It says log base on it. Okay, select that. And it's going to pop this up on your screen like this, and you literally type it in. So you put a 2 down here and an 8 there, and you should get 3. Log base 2 of 8 is 3. Now, if you do not have a graphing calculator, if you have a scientific calculator, then here's how you're going to do this problem. So we're doing log base 2 of 8. You're going to use something called the change of base formula. To do the change of base formula, you're going to do the log of the number you physically wrote larger. So you're going to do log of 8, and you're going to divide it by the number that you physically wrote smaller, log of 2. Okay? So if your calculator does not have this log base function where you can change the base, then you want to do it this way. And you should also get 3 by doing that. What mode do you have? What model? 83 does not have it. You're going to have to do it as log of 8 divided by log of 2. Okay, any questions? Okay, that's how you do your log problems. So you're going to do the same thing on that for the next two problems, for 33 and 42. So we're going to skip over those. Let's go to ACT number 60 at the bottom. On the left side, you have log base 2 of 24 minus log base 2 of 3. Those are all numbers. Just type that straight in to your calculator the way it looks. Again, if you're not using the TI that has the log base function, you're going to have to do log of 24 divided by log of 2 and log of 3 divided by log of 2. So math, arrow down, log of base. Okay, so it should, once you put it in, if you're using the log base function, it should look like this, and you should get 3 again. And again, if you're not doing that, it's log of 24 divided by log of 2 and log of 3 divided by log of 2, and then subtract the two values, and you should get something close to 3. Okay. So the left side of this equation is 3. So we're going to wind up with this one with 3 equals log base 5 of x. And you got to figure out what x is. Well, we don't want to have to solve log equations. That's not something we want to have to do. But we have numbers in our answers. So what do we do with numbers in our answers? Plug them in. So start with C, plug in 72. Is log base 5 of 72 equal to 3? So again, either do your math log base or log of 72 divided by log of 5 and see if it gives you 3 or something very close there too. If it does, then you have your answer. If not, then you either got to move up or down depending on where you get too high or too low. And the one that should work in that case is 125. It should be D. Okay. Yeah. If you plug in 125 here, you should get 3. If you do log of 125 divided by log of 5, you should get 3. Or if you do log base 5 of 125, you get 3. All right. DRT problems, distance, rate, and time problems, we're actually going to skip over because they're not very common at all. And you guys will have the answers to those. And if anybody has questions on them, come Thursday and I'll explain them. We're going to do stats problems because those are much more common. So I need packet. There we go. Okay. So your stats problems, these are SAT only problems, and that's what you're getting ready to take. Most of you are getting ready to take on Wednesday, so I want to make sure we hit these. The stats problems we're going to look at are alternate ways to calculate medians using a frequency table, which is what this is. Standard deviation, population extrapolation, margin of error, and random sampling. Okay, so an alternate way to calculate a median using a frequency table. Let's look at this guy. So I'm not going to read through all this. There's a whole bunch of information here that we honestly don't really care about. It's just garbage. Here's our question. Which of the following could be the median score in study 3? Okay, so we're looking for the median in study 3. So if we go back up to our table here, I'm looking for the median in study 3. So I don't care about 1, don't care about 2. And for study 3, I don't care about the mean. I'm going to get rid of that so I don't accidentally look at it. Study 3. Study 3 has 300 participants. Okay. Now, normally when you find a median, what you want to do is list out all the stuff and then hack away at the ends until you find the middle, right? There's 300 numbers. I don't want to list out 300 numbers. Plus, I don't know all 300 numbers. I know that there's 88 of them between 50 and 59, but I don't know what they are. That's going to make my life difficult. So I'm not going to list all those guys out. So let's figure out another way to do this. If there's 300 people in line, where's the middle guy? What position is he in? 150. So I need to find the 150th position. Okay, so I need to go in either 150 from the top or 150 from the bottom. So let's go 150 in from the top. So 150 minus 88. So 150 minus 88, which I apparently cannot type in the calculator, is 62. So I'm going to get through this category, and I'm going to have 62 people left over. So I'm going to get out of that category. I got 62 people left over. Am I going to get out of the next category? No, I'm going to get stuck there because there's 67 people there. That means my median is somewhere in this next category, which has a score range of 60 to 69. So my median is somewhere between 60 and 69. I don't know where. I just know it's in that category. Okay, so my answer has to be somewhere between 60 and 69. The only answer between 60 and 69 is 68, so my answer has to be B. Okay, ma'am.
What if there are multiple answers?
There won't be. There won't be. No, because you can't specify. There's no way to do that. All right. Your next question is about random sampling. So the word random means different things depending upon what class you're taking. If you have AP Stat or something, the word random means something different than what it means in your SAT. For your SAT, the word random simply means, does everyone have a fair chance of being picked? That's the definition of random, okay? So here we go. 100 Park District members will be selected to participate in a survey about selecting a new Park District coordinator. Which of the following methods of choosing the 100 members would result in a random sampling of members of the Park District? So we're looking for which one would give us a random result. A, obtain a numbered list of all Park District members and use a random number generator to select 100 people from the list. Well, if I'm looking for a random sample and you're using a random number generator, that sounds pretty good. Well, yeah, okay, we're good with that. B, obtain a list of all Park District members sorted alphabetically. That's not random. We're only giving the survey to the first 100 people on the list. If your name starts with Z, you have no chance of getting picked. So B is out. Again, everybody needs a fair chance of getting picked. C, tell all Park District members that volunteers are needed to take the survey. Anything involving volunteers is never random. Okay, you're only going to get people that want to do something. So not everybody has a fair chance. D, obtain a list of all Park District members who are attending an upcoming event and give the survey to the first 100 people. Nope, I'm only going to get people going to the event. It's got to be A. Okay, so that's a random question. Ta-da. Next. I hate stats questions. All right, margin of error. Margin of error questions are actually really, really easy. All you have to do is add and subtract the numbers they give you, and then you look for a word that is absolutely liquid gold when it comes to stats. And we'll go over that. So, Parks and Ranger asked a random sample of visitors how long they hiked during their visit. Based on the responses, the estimated mean was 4.5 miles. Associated margin of error of 0.5, which is following is the best conclusion from the data. Anytime you have margin of error, add and subtract the number. So 4.5 plus or minus 0.5. If I subtract it, I get 4. If I add it, I get 5. My answer must contain those two numbers. So if I go to my answer choices, I can rule out B and C. My word in stats problems that is absolutely liquid gold is right here. Plausible. If you see that word plausible, that's going to be your answer. Always watch for it. My answer is D. Okay. Nothing is certain in stats, so they always want plausible. 10 you can do on your own. 7 you can do on your own. Population extrapolation. So population extrapolation. So what this is it's talking about, let me just give you an example. Let's say I went to Newsom High School and I took 20 freshmen from the school. I asked them a bunch of questions. I found the results to be statistically significant, and then I wanted to draw conclusions based on those results. Okay? I could only talk about the freshmen at Newsom. I can't talk about the whole school. I can't talk about all freshmen in the county. I can only talk about where I got those kids from. So if I take 20 freshmen, I can only talk about the freshmen at Newsom. Okay? Does that make sense? All right, that's as far out into the population as I can go. I can only go as far as where I took those kids from. So here we go. A scientist conducted an experiment and selected a random sample of runners from, okay, pay attention where they came from a list of all high school track participants from a certain city. All right, that's where they came from. The scientist randomly assigned each runner to one of two treatment groups. The results of the experiment found to be statistically significant. Which of the following populations can the results of the experiment be safely generalized? Where did he get them from? All high school track participants from a certain city. Where can you generalize? All high school track participants from a certain city. There we go, word for word, boom. Okay? Don't overthink these, just match it up to where he got the kids from. Make it a sense? All right. Again, these are pretty straightforward. So this one you can do on your own. That one you can do on your own. Don't make those hard. Standard deviation. So standard deviation, basic concept here, guys. Standard deviation is just the distance something is away from the mean. That's all it is. How far away from the mean is something? That's it. Okay? The higher your standard deviation, the more spread out your data. Okay, that's all you need to know. Now they will use standard deviation and variation interchangeably on the SAT. They are not the same thing. Okay, in a stats class, your teacher would be like, that's not the same. On the SAT, they are. So just roll with it. 2 independent surveys asked random samples of 500 people about the distances they commute to work each day. The results of the survey are detailed in the table to the right. Which statement is true based on the results of the survey? There is greater variation, aka standard deviation, in the distribution of the distances people to commute and work in survey A. Variation, standard deviation. They're the same. Okay? So your standard deviations are the same, therefore your variation is the same, according to SAT. So that would mean that C is correct and the other 3 fail. The variation is the same in both surveys. So this one should be C. Questions on that? All right, let's talk about calculating standard deviation. You never want to do this by hand. So we don't. This is one of those things that if you have a graphing calculator, you can do this. If you don't have a graphing calculator, you're simply going to take your best guess on these problems and move on. The good news is you're maybe going to have one of these problems on the test, maybe. You may not ever see this. So if you don't have a graphing calculator, don't panic. If you do, let's look at how to do this. So the table to the right shows 2 lists of numbers. Which of the following is true statement comparing list A and list B? So we want to calculate the means and the standard deviation. All right. So back to calculator land. So first thing we're going to do is go into our stat menu. Your stat menu is right next to your arrow keys. So look for your arrow keys and go 1 to the left. You'll see the word stat. Click on stat. Brings up this lovely menu right here. We're going to choose edit, this very first option. And it's going to bring up a bunch of lists. Yours are probably going to be blank. Mine have stuff in them. Put list A in list 1 and put list B in list 2. Which are those numbers, by the way. Don't worry about list 3 and list 4. Just ignore that. Okay. Once you have those entered, go back into your stat menu. So back to stat. And we're going to arrow right one to calc, which stands for calculate. We're going to choose this very first option, this one variable statistics, one bar stats. Okay. Go back to your stat menu. Arrow right one to calculate. And choose this very first option, one var stats. Should bring up something that looks like this. Now make sure you have list one right here. Yours doesn't pull that up? Okay, hold on a minute. Let me get everybody else here. If it does not say list one here, then you want to change it to list one. The way to change it to list one is to use your second button, which is blue in the upper left, and then hit the number one. Once it says list one, arrow down to where it says calculate and hit enter. And it's going to give you a whole bunch of gobbledygook. It's going to give you a whole bunch of stuff. When we go to play the game, give me your calculator and I'll play with it. I'll figure it out. Okay. So you're going to have this mess. Now, what you need out of this are just a couple of things. This right here, this X bar, that's your mean. Okay? There's two different ways to calculate standard deviation. They're right here, S of X, and then this is sigma, sigma of X. The one that your SAT wants is this guy right here. This is your standard deviation. Okay, so those are the two numbers that you need out of all this gobbledygook. So for list A, our mean is 3.5 and our standard deviation is sigma, is 1.707. So that's for list A. For list B, you're going to go back through the same process. So for A, our mean is 3.5 and our standard deviation is 1.708. Okay, so to get list B, we're going to go back into stat. Again, go to calc, choose one variable statistics, but this time we want to change it to list 2. So to change this to list 2, hit your blue second button and then your number 2. And that should change it to list 2. And arrow down to calculate and hit enter. And again, it'll pop up all the gobbledygook. And you can pick out your mean and your standard deviation. So for list B, your mean is 3.5 again, and your standard deviation is 0.96. Okay? And then you can actually answer the question. So the answer to the question, they just want to know, it says the means are the same and the standard deviations are different. The means are the same, the standard deviations are the same. The means are different, the means are different, blah, blah, blah. So it's going to be A. Your means are the same and your standard deviations are different. Okay. So that's how we figured that out in the calculator. All right. The next one you can do as practice. Again, it's the same thing we just did. The numbers are just gross. All right, and last up is matrix problems. Matrix problems are only on your ACT? No, don't save. These can be put in the calculator, but honestly, it takes longer to put them in the calculator than it does to do by hand. Matrix problems can be solved just with some basic common sense. If you're adding or subtracting matrices, all you're doing is adding or subtracting stuff that's in the same position. That's all you're doing. So which of the following is A minus B? We're literally going to subtract upper left minus upper left, upper right minus upper right, lower left minus lower left, and lower right minus lower right. That's what we're doing. Okay, so don't overthink matrix problems. So upper left minus upper left would be 3 minus negative 7. Negative 5 minus 6 would be upper right. Lower left minus lower left. negative 2 minus 4, and lower right minus lower right, 9 minus 5. Okay, there we go. 3 minus negative 7, that's 10. We got negative 11, we got negative 6, and we got 4. Z. Okay. So adding or subtracting matrices, that's all you have to do. You will not be asked to multiply or divide matrices. So you don't have to worry about that, because that's a long and gross and disgusting process. Determinants. You will be asked to find a determinant. Now the good news is you don't have to know how to do that. They're always going to give you the formula in the problem. So the determinant of a matrix ABCD equals AD minus CB. It's right there. What must be the value of x for the matrix X8XX to have a determinant of negative 16? So let's just match stuff up. ABCD. A, B, C, D. And then plug it in your formula. A times D would be x times x, so that's x squared, minus CB. C times B would be 8x. And we know it's going to have a value of negative 16. Ta-da! Okay. And then we just have to solve this for x. So move the 16 to the other side. And solve for x. So factors the 16 that add to give me negative 8. X minus 4 times x minus 4. So x must equal 4. There you go. Done. Okay. Again, they'll always give you the formula for determinant, so you don't have to know how to do it. All right, last one. Given that A times this matrix equals that matrix for some real number A, what is x plus z? So, distribute, okay? You've got A out front of something that looks like parentheses. What do you do with a number out front of parentheses? You distribute. Same thing with matrices. Just distribute it through. We've got 2A, A, 6A, and 4A. And that's equal to x, 27, y, and z. And again, we're going to apply just a little common sense. The upper left equals the upper left. Upper right equals upper right. Okay? We're just going to set the same positions equal. So 2A equals x. 6A equals 27. A equals y. And 4A equals z. Now they want to know what x plus z is. Well, I got to solve for those first. So I have 4 equations here, and I'm going to solve this a smart way. I'm going to look for which one is actually going to give me a number. 6A equals 27, I can get the value of A. Divide both sides by 6, A is going to be 4.5. Which makes Y also 4.5. It makes Z equal to 18, and X equal to 9. And then they wanted to know what X plus Z was. X is 9, Z is 18. 9 and 18 is 27. Ta-da, done. All right. So we only have 20 minutes. The game takes